Welcome to Study Loop.
Hello everyone, today we're doing problem 23, or chapter 23, problem 68, and this problem asks us devise a synthesis to generate this drug using these two starting materials and any other organic or inorganic reagents needed. So we see that we have the same kind of backbone as this structure, but we're changing some identities of some substituents. So we have these electrophilic or electronegative bromine groups attached to these electrophilic carbons, and we're changing them for the cyano groups, and then we're alkylating these alpha positions, and then we're also alkylating this allylic position up here. So what we need to do is easily we can add sodium cyanide to SN2 attack to change the bromines to cyano groups, and then what we can do is first we'll add in a strong base to deprotonate these alpha carbons so that we can alkylate them. And after these positions are alkylated, we can use bromine and light, the radical initiator, to brominate the allylic position. So we want to do this very last because we don't want to brominate these positions by accident. And then this imidazole group would come in and attack these positions because we want to occupy these positions such that there's no more protons left, and so then this imidazole attacks on the top. So let's begin. So we have this starting material, and then we're going to add 2 equivalents of sodium cyanide. Now we have 2 alpha positions here and here with alpha carbons and alpha protons. So we can add 2 equivalents of sodium ethoxide with 2 equivalents of our alkyl halide. And then that's going to make these alpha carbons into carbanions, nucleophilic carbanions, which can then go through SN2 attack of our alkyl halide to get alkylation at those alpha positions. And then we're going to repeat this entire step to remove the second alpha protons of each of these alpha carbons to add a second alkyl group. And now we can add Br2 and light to brominate this allylic position such that we can add this nucleophile to do an SN2 attack on this position to give us the final product. So we can brominate the allylic position now that all the other allylic positions are fully occupied, so we won't accidentally brominate those positions. So we brominate the allylic position, and now if I react this with, or now if I take my imidazole and I react that with sodium hydride, and sodium hydride is going to deprotonate this proton to make N-, and then this N- can do an SN2 attack at this electrophilic carbon position. And now we have our final product in our question stem.